is equal to pi square. Let's try to solve a very good example. For any real number x, let this denote the largest integer function less than or equal to x. Let f be a real valued function defined on the interval -10 to 10 by fx equal to x minus greatest integer function of x if the greatest integer function of x is odd, and is equal to 1 plus x minus the greatest integer function of x if the greatest integer function is equal to even. Find the value of pi square by 10 into integral of fx into cos of pi x from -10 to 10. So in this problem we have been given that f is a real valued function and it is defined on the interval -10 to 10. Now fx is equal to x minus the greatest integer function of x if the greatest integer function of x is equal to odd, and is equal to 1 plus x minus greatest integer function of x if the greatest integer function of x is even. So from this we have to find the value of pi square by 10 into integral of fx into cos of pi x from -10 to 10. So let's try to see the solution of this. Let's take the first case. When x is greater or equal to 0 and less than equal to 1, then the greatest integer function of x would be equal to 0, and we know that 0 is an even number. Again, when x is greater than equal to 1 and less than 2, then the greatest integer function of x is equal to 1 and 1 is an odd number. Similarly, when x is greater or equal to 2 and less than 3, then the greatest integer function of x is equal to 2, and this is an even number, and so we can calculate for different values of x. Now fx is equal to 1 minus x when x lies between 0 and 1. This would be equal to x minus 1 if x is greater or equal to 1 and less than 2. Similarly, this would be equal to 3 minus x if x is greater or equal to 2 and less than 3. This would be equal to x minus 3 when x is greater or equal to 3 and less than 4, and so on. We can calculate for different values of x. So what we do next is we try to plot the graph of fx. Now when we plot the graph of fx, we get this as the graph of y equal to fx, and this is equal to 1 minus x when x is greater or equal to 0 and less than 1, so this is 1 minus x. Now this becomes x minus 2 when x lies between 1 and 2. This becomes 3 minus x when x is greater or equal to 2 and less than equal to 3, and so on. Now what do we see so special in this graph? We see that the value of fx repeats its value after a fixed interval. So fx is a periodic function. Also we see that it repeats its value after an interval of 2. So the period of fx would be 2. Also one important point to note is we clearly see that this is symmetrical about the y-axis, and if the graph of a function is symmetrical about the y-axis, then it is an even function, and so we can say that fx is an even function because its graph is symmetrical about the y-axis. Thus we can say that fx is a periodic function and the period of fx is 2. Also fx is an even function. Now let's look at cos of pi x. We know that cos of pi x is an even function and it is periodic with a period of 2 because 2 pi by pi is equal to 2. Hence cos of pi x is periodic with the period 2. And so we can say that the whole integral, that is fx into cos of pi x, is an even function and is periodic with the period of 2. Now let's try to calculate the value of the integral. Let us say that I is equal to integral of fx into cos of pi x dx from -10 to 10. Now this is an even function, so we can write it as I equal to 2 times integral of fx into cos of pi x dx from 0 to 10. Because the period of this is 2, so we use the property that integral of m times t to n times t of fx dx is equal to integral of 0 to t fx dx into n minus m. So we get I equal to 2 into 5 into integral of fx into cos of pi x dx from 0 to 2. Now what we do is we break this into intervals. So this I would be equal to 10 into integral of 0 to 1 fx in this range is 1 minus x into cos of pi x dx plus integral 1 to 2 x minus 1 into cos of pi x into dx, because fx is equal to 1 minus x when x is greater or equal to 0 and less than 1, and is equal to x minus 1 when x is greater or equal to 1 and less than equal to 2. Thus I would be equal to 10 times integral of 1 minus x into cos of pi x into dx from 0 to 1 plus integral of x minus 1 into cos of pi x dx from 1 to 2. Now when we try to solve this further, we get the value of I equal to 40 by pi square. So we can say that pi square by 10 into I is equal to 4. Till now we have seen how to differentiate a function, how to integrate a function, but now let's see a very unique concept, which is the differentiation of integrals, and for that we have to study the Leibniz rule. It says that d by dx of integral of f of t dt from gx to fx is equal to h of fx into f dash x minus h of gx into g dash x. So here we see that h is a function of t, so the variable here is t. Also the limits are two functions of x. Let us say that these are fx and gx. Once again, h is a function of t and the upper and lower limits are functions of x. So when we try to differentiate with respect to x, we get this as equal to h of f of x into f dash x minus h of gx into g dash x. So this is the Leibniz rule. Now if fx is equal to x and gx is equal to 0, then particularly for such case t by dx of integral of f of t into dt from 0 to x is equal to f of x. So this is the Leibniz rule. Now let's try to see the proof of this. Let us say that the integral of hx is equal to px. So the antidifferentiation of hx is p of x. So h of x would be equal to p dash x. So what we do here is we take the limits from gx to f of x. So the integral of hx from gx to fx would be equal to p of f of x minus p of g of x. Now let's try to differentiate both sides. So when we differentiate both sides, we get d by dx of integral of h of x from gx to fx is equal to p dash of fx into f dash x minus p dash of g of x into g dash x. Also we know that hx is equal to p dash x, so this would be equal to h of f of x into f dash x minus h of g of x into g dash x, and hence this is nothing but the Leibniz rule. Thus we have proved the Leibniz rule. The second rule is if f of t is equal to the integral of g of x comma t from a to b into dx, here g is a function of x and t, then df by dt would be equal to integral of del by del t of g of x comma t into dx from a to b. Here this is nothing but the derivative of g with respect to t keeping x as constant. So this is actually the partial differentiation of g with respect to t. Here what we do is we treat x as constant and we differentiate g with respect to t. So let us try to solve one more example. This problem appeared in IIT JEE 1998, and it says that the integral of f of t dt from 0 to x is equal to x plus integral of t times f of t from x to 1. Then the value of f of 1 is, option number A is 1 by 2, option number B is 0, option number C is 1, and option number D is minus 1 by 2. So in this problem we have been given this equation, which is integral of f of t dt from 0 to x is equal to x plus integral of t times f of t dt from x to 1. Then find the value of f of 1, and we have been given the four options. Now how to solve such a problem? Let's try to understand. Now we have been given this equation. Now we see that the upper and the lower limits are in the form of function, so definitely we have to apply the Leibniz rule here. Thus when we differentiate both sides using the Leibniz rule, we get f of x into 1 equal to, the differential of this is 1 minus x times f of x into 1. So when we use the Leibniz rule to differentiate this equation, we get f of x into 1 equal to 1 minus x times f of x into 1. From this we get 1 plus x into f of x equal to 1, or fx equal to 1 by 1 plus x. So now we know the value of fx, we can easily find out f of 1. So f of 1 would be equal to 1 divided by 1 plus 1, which is equal to 1 by 2. So f of 1 is equal to 1 by 2, and this is nothing but option number A. So option number A is correct. Let's see one more example. This problem appeared in 1988, and it says that investigate for maxima and minima of the function fx equal to integral of 2 into t minus 1 into t minus 2 whole cube plus 3 times t minus 1 whole square into t minus 2 whole square dt from 1 to x. So again here we see that here the limits are functions of x, and also in this problem we have to investigate the maxima and minima of the function fx. So let's see the solution of this. So we have been given the expression fx equal to integral of 2 into t minus 1 into t minus 2 whole cube plus 3 times t minus 1 whole square into t minus 2 whole square dt from 1 to x. Now we see that the limits are expressed as a function of x. Also we have to investigate for the maxima and minima of fx. Now we clearly know that for points of maxima or minima, f dash x is equal to 0. So what we have to do is we have to find f dash x, and it should be equal to 0 for finding the points of maxima and minima. So the first step would be differentiating both sides with respect to x. And for differentiating an integral, we have the Leibniz rule. So we apply the Leibniz rule to calculate f dash x, and so f dash x would be equal to 2 times x minus 1 into x minus 2 whole cube plus 3 times x minus 1 whole square into x minus 2 whole square into 1 minus 0. So f dash x would be equal to, we further simplify it as x minus 1 into x minus 2 whole square into 2x minus 4 plus 3x minus 3. This further simplifies to 5x minus 7, and hence f dash x is equal to x minus 1 into x minus 2 whole square into 5x minus 7. So for critical points, we know that f dash x should be equal to 0. Thus we get the values of x as 1, 2, 7, 5. So these are the critical points. Now how to decide which point represents a point of maxima or which point represents a point of minima? For that we have to again differentiate f dash x. So f double dash x would be equal to 10 times x minus 12 into x minus 2 whole square plus 5 times x square minus 12x plus 7 into 2 into x minus 2. So this is the expression for f double dash x. Now if f double dash x is less than 0, then it represents a point of maxima, and if f double dash x is greater than 0, then it represents a point of minima. So f double dash x is equal to minus 2 at x equal to 1. It is equal to 0 at x equal to 2, and is equal to 18 by 25 at x equal to 7 by 5. Thus this is a negative value, this is 0, and this is a positive value. So we can say that x equal to 1 is a point of maxima, and x equal to 7 by 5 is a point of minima. The point x equal to 2 is neither a point of maxima nor minima. Now let us try to study the inequalities involving definite integrals. So the first is, if f of x is less than equal to g of x for the interval x greater or equal to a and less than equal to b,